Doug Brake. I'm a telecommunications policy analyst here at ITIF. ITIF, we're a nonprofit, nonpartisan, independent think tank. We focus on innovation policy and the digital economy. So I want to thank you all for joining us. I think as we're all pretty well aware at this point, there's only so much attention that you can pay to the net neutrality issue before we all go completely insane. And there's a lot of competition in this city for your limited amount of net neutrality attention. So I'm happy that you all were able to join us today and spend a little bit of that net neutrality attention here with us. So I think the point of this panel is I think so much of the discussion around net neutrality for the last year has really focused on a lot of the broader policy issues that are more to do with the legal classification of broadband, and not so much to do with the actual specifics of net neutrality, not the specifics of the technology or how a sort of regime of reasonable network management would actually be regulated, even what reasonable network management really means. So we wanted to bring together a panel of engineers to discuss sort of the actual specifics of the technology, what prioritization is, what network management is, the actual real network neutrality issues. Because to be honest, it seems to me there are a lot of reasons not to like Title II. Some could argue there are reasons not to like 706. But on the very specific narrow issue of net neutrality, either way, we're talking about reasonableness. Under Title II, it's a standard of just and reasonable. Under 706, it would be a standard of commercial reasonableness. And either way, we're going to have to eventually get down to the nitty-gritty of what reasonableness really means. So we wanted to bring together some engineers to get into those issues. I'm hoping to sort of kick off with a sort of an example, that of the Comcast BitTorrent dispute. I think to my mind, this represents a great example of where sort of engineering technical details got lost in a lot of the broader debate. So I am, by training, a lawyer, not an engineer, so I welcome any of the engineers to correct my amateur characterization of what went on in the Comcast BitTorrent dispute. But my understanding was that BitTorrent was congesting a lot of the upstream traffic that was especially problematic in the shared cable plan. So essentially, BitTorrent would take over a rather greedy protocol that would take over and congest entire links. When it filled the upstream traffic, that would create severe problems in terms of latency that would dramatically affect other applications. So Comcast, in order to solve this problem, would send signals to BitTorrent protocol, essentially indicating to the TCP protocol that packets were being dropped and that it should back off, it should slow down and not take up quite as much bandwidth. To my mind, this is perhaps not the best way to go about solving the problem, but it is not, by no means wasn't blocking BitTorrent, right? This is a way to try to resolve a problem around congestion that was having a harmful effect on other users of the network. But I worry that in the broader cultural consciousness, this has been picked up as Comcast blocking BitTorrent. And that argument has been made, and I think to a large extent sort of kicked off a lot of the net neutrality discussion that has continued since 2010. I think that it's exactly issues like those that we need to have sort of institutional structure to allow engineers like those we've gathered today to actually express what is actually going on within the network and the ways that we can solve these sort of congestion problems. So without further ado, briefly introduce our panelists. I won't run through their entire biography. We've got bios available online if you're interested. We have Charles Jackson. He's an adjunct electrical engineering professor at GWU. John Peha, professor of public policy and computer science at Carnegie Mellon and former chief technologist of the FCC. And we've got Peter Raisavi, who's an independent consultant and founder and president of Raisavi Research. Without further ado, Charles, would you like to kick it off with a few remarks? Yeah. by means of format, we're just going to sort of go down the line with some opening thoughts, points of discussion.
Okay, well, I have just 3 quick points I'd like to make, and then maybe at the end I'll come back to some comments on the Comcast BitTorrent issue if my time permits. My first point is I'm not very worried about the impact of network neutrality rules, whatever they are, on the Comcast and Fios and other wireline service providers in the internet world, internet access world. And I think the reason I have for the 2 causes for that feeling, and one is in those systems there's a very low marginal cost per bit. So if somehow regulation causes a 10% inefficiency, well, you hardly notice it because they turn the gain up on the system and generate another 10% bits. And then there's regulators often turn out to be very pragmatic when faced with specific cases rather than issues of general principle. So if there is a dispute, I suspect that the Commission will be more driven by the facts of that specific case than concerns about censorship and free internet and all those other things, but more the specifics, and we'll find more pragmatic decision making. So given that, I don't worry much about the Comcast and Fios of this world. In contrast, my second point is I'm quite worried about the impact of network neutrality rules on wireless. And that's for 2 fundamental reasons. I believe Peter's going to say much the same, but I get to say it first. I was afraid he'd go first, and then I just have to say ditto. But I think we'll have somewhat different interest. In wireless, there's a much higher marginal cost per bit. Wireless bits are essentially quite expensive, and there are very different kinds of capacity trade-offs inside wireless networks. Give 2 brief examples, no equations. First, consider a situation where we just have a wireless network with 1 base station and 2 users, Alice and Bob. And Alice is very close to the base station and gets a big strong signal. And if 100% of the capacity of the base station is devoted to communications with Alice, she can communicate at 10 megabits per second. And there's another user, though, Bob, who's much farther from the base station. And if 100% of the base station capacity is dedicated to communicating with him, he can get 1 megabit per second. And this is really what you see in real world wireless networks. If you're next to the base station, you get those really high speeds, LTE promises, and if you're out on the edge of the service area, you get far less. Now, which of the following 2 alternatives would you regard as being network neutral? A world in which Alice gets 5 megabits per second and Bob gets 0.5 megabits per second. That's a world where, in some sense, Alice's bits get 10 times the priority of those given to Bob, but they get equal shares. They're each getting 50% of the base station capacity because the radio link is so different for them. Now you can think of a different world in which both Alice and Bob get about a tad less than 1 megabit per second, maybe 0.9 megabits per second. Their bits are being treated equally. Each of Alice and Bob have an equal probability of getting their bits transmitted by the base station. But Bob is getting 90% of the base station capacity, and Alice is getting about 10%. And the total system throughput has fallen from 5.5 megabits per second to 1.8 megabits per second, which, if I did my arithmetic quickly, is about a loss of 2/3 of the system capacity. That's a big hit. But which of those 2 alternatives would you regard as being network neutral? And what kind of definitions would allow you to say, we're going to treat all bits the same, but we're going to allow the network to operate in the first far more efficient mode, or far higher total throughput mode, than in the second? Here's a second, somewhat related wireless example. As you're all familiar, the quality of the radio connection varies. Sometimes it's very strong and crisp, other times you barely get through, and finally it fails. And the connection quality in a wireless system varies rapidly with time. It could vary by a factor of 10 in a fraction of a second. So if a base station waits a little while before communicating with a user, they might have a much better channel to communicate over. If we have a rule to say that all bits are treated equally. That is, if you're going to wait on average a tenth of a second for one user, you have to wait a tenth of a second on average for all users. You can't give any bits faster access to the channel. Then if you treat all bits equally, we have sort of two alternatives. One, voice service works, because we never wait very long, we get those voice packets through. But the whole system capacity is low. Or we can have high capacity, because we tolerate longer delays, but those delays make voice service unacceptably poor. Now there's an alternative. If we give voice bits priority, then we have a system where voice works, and we have an intermediate capacity. And that intermediate capacity, I didn't check this before coming here today, but I've done analysis in the past, is about 50% higher than in the world where we treat all bits the same and voice works. If we're willing to say, well, we have some background bits that we transmit when the capacity isn't needed for the high priority voice service, we can gain another 50% of throughput. But how can you which of those three alternatives, obviously, if you treat all bits the same, high capacity, low capacity, and voice works or not works, but the alternative, which might be attractive in many situations where voice works and you have intermediate capacity, seems to me to be ruled out by any literal-minded approach to network neutrality. And then my third point is just when I think about these issues, and try to see how I feel about various topics, I sort of think that the Rawlsian veil of ignorance is a great approach. And it seems to me, for example, that I think anyone would like the option of being able to use VoIP. That's because I use Vonage and I like it. So I think everybody would like it. And therefore, I think that in any world of network neutrality, something like voice should be allowed priority other kinds of applications. Now, I don't know whether that conclusion shows the power of Rawlsian veil of ignorance analysis or is a devastating criticism of allowing engineers to think about Rawlsian analysis. But those are my 3 points. I'm worried about wireless. I'm not worried about wireline. And I think if you stand back and think about what kind of world you'd like if you could be anybody, it might help understand the trade-offs between priority and non-priority. With respect to Doug's comments on the Comcast issue, I think he was correct that BitTorrent, combined with a problem called buffer bloat, which is basically when you go through, as funny as it sounds, memory got cheaper, so the designers said, well, we've got buffers in our routers, and buffers are good, memory's cheaper, we'll make the buffers bigger. That turned out to be a real bad idea, but if you combine BitTorrent with user devices that have buffer bloat, when a user's, the person who's paying money to Vonage has a Vonage account and their teenage child is upstairs playing, running a BitTorrent server, all of a sudden their Vonage service, the engineering term I think is goes to hell, right? And so when this started occurring, Vonage started writing lawyer letters. You guys can explain that. Lawyer letters to Comcast saying, "Why are you guys crashing? You're destroying our voice over IP service just to advantage your voice service." And apparently, the first reaction at Comcast was, "What?" And then they went and investigated it, and they said, "Oh, okay, well, we'll fix it." And I guess I got a slightly different line of recollection. I haven't looked at it in a few years, so I could easily be wrong. My recollection is they didn't exactly slow it down the way Doug described it. They inserted a thin bit in the TCP connection and caused it to hang up. And BitTorrent was kind of smart, so it could recover from that. But it was as slowed down as they could make it. And subsequent to that, people at BitTorrent have tried to work on developing other protocols that don't have this same flaw. I think if you look up IETF, you'll see something called LEDBAT, L-E-D-B-A-T, if I recall correctly, that has less of these problems and is less of a bad neighbor with the rest of the internet than the early BitTorrent was. But it was very unfortunate that this attempt, I think, by Comcast to do the right thing in the beginning was so misunderstood. And maybe if they'd been more open and explained from the beginning what they've been doing, it might have had the same political reaction.
Thank you. John, would you like to take over? I believe you have some slides.
I do. I'm very tempted. I don't know. Chuck said a lot of really interesting things, as Chuck usually does, and part of me really wants to respond to them. And I also would think differently about Comcast, and I'm tempted to jettison my slides. But since I threw them together last night, why don't I will do that, and I'm sure we'll get back to some of these issues. Okay. Let's see if this magic works. So I said this is about the issues that matter for policy, which, sort of echoing some of Doug's comments, was kind of a backlash to this eternal debate we're having over reclassification, as if it were a discussion of policy, and it's not.
Just tell us next slide.
Did I do that or you? So reclassification is not a policy. Let's start there. Right? There's a lot of discussion about which legal authority the FCC should use. Should they use Title II? Should they use Section 706? There are a lot of people who are talking as if choosing your legal, the FCC should choose its legal authority to give you the good policy. This is both a misunderstanding of the technology and a misunderstanding of the law. There are two separate, related but separate issues here. There is what is the legal authority, which I believe should be about looking at the technology we use in 2015 and applying the law, which is the Telecom Act of '96 definitions, and deciding where it goes. That's what following the law means. And then there's the policy, because whichever way the FCC goes, they actually have a lot of flexibility in terms of deciding what policy to adopt, and they could do it well or they could do it poorly. And the so-called technical issues that are coming up here are really much more about whether it's an effective or ineffective policy, and they somehow get pushed aside. So I'm glad we get to discuss them a little here. Also, it is worth pointing out that we don't know what the FCC is going to do on the detailed issues. People are talking as if the policies were known. They're not, only the very high-level press release. So at the core of the open internet and net neutrality, I think, is the discrimination issue, which is clearly related to quality of service. Discrimination and prioritization, including prioritization, which to me is one kind of discrimination. Our misunderstanding about those two words may cause us lots of problems. Discrimination makes differential quality of service possible. That's what Chuck was talking about with FOIA. Discrimination can be a wonderful thing. I would argue reasonable discrimination can be very good. It can make applications that we really care about possible, or at least possible in a way that we want to use them. Very important. It can make it similarly possible to meet everybody's quality of service objectives with lower capacity, and therefore in some systems where capacity is expensive, lower cost. Very important. Also, we're talking about discrimination in blocking. You can block security threats. That's a good thing. But discrimination has a darker side. It can also allow an internet access provider that has sufficient market power to become a gatekeeper, to protect either legacy or affiliated content or application service providers. But even without an affiliate, to extract rents on otherwise competitive markets for content and application service providers. And perhaps to inhibit innovation. So there's a balancing act here. It's not simple as either side sometimes likes to portray it. And nothing unusual about that. Lots of policy issues have balancing acts. I personally have proposed something that I think is somewhat in the middle, which is we should allow we should prohibit unreasonable discrimination. We should allow reasonable discrimination. It's not a new formulation, but we'll say, all right, internet access provider, it is perfectly okay to offer differential quality of service. It's perfectly okay to offer differential pricing. But to be reasonable, if an internet access provider offers superior quality of service to one user, then they have to offer that same service to similarly situated other users at the same quality of service, terms, and conditions. That's what I've argued to the FCC. We don't know yet whether they've listened to me from the high-level press release. To get a little more into the weeds, one of the things I'm particularly worried about, paid attention to, is something called a specialized service or managed service. The 2010 rules identified something different called a managed or specialized service. And this, to me, was something that's not internet. If I want to establish a private network between me and the 5 people I work with, and my ISP provides that to me using IP and their wires, it's not internet. It may use IP, it may use their wires, it's not internet. We don't necessarily want all those open internet rules to apply to that specialized service. But some people are now expanding to what could be a huge loophole. By some arguments, anything where you do any kind of differential quality of service or any kind of blocking of content or applications is a specialized service, and anything that's a specialized service is exempt from open internet rules. You put those things together and you effectively eliminate the open internet rules. I honestly don't know how to break these rules if I want to. Right? The mere act of trying to block some applications means the rules against blocking applications become inapplicable. So, if we don't want open internet rules, we should just skip it and not make them instead of having a big loophole. So what I see is 3 sets of very complicated rules became intertwined to become even more complicated. There are rules about what kind of discrimination is allowed and is not allowed in general internet traffic. We need to get those right. There are rules about what is a specialized service. We need to get those right. And there are rules about that apply to specialized services, and we need to get those right too, and they're all fit together. So I, for example, have said, one great way to do this is to say, let's allow reasonable discrimination for all internet traffic. Allow, not unreasonable, but allow reasonable, and we can talk more about what that means. And then have a very narrow definition of specialized service that's largely exempt. Maybe some transparency rules, but mostly it can be exempt. Or we can do as some suggest and say specialized service is anything that has differential quality of service, which is a really broad definition. But now it can't be exempt. There have to be rules that apply to it too. And I hope the FCC gets this right. I guess the bottom line of this is for all of this, the devil is in the details. And the details are interrelated in subtle ways. So you've got to kind of look at them all, and we can't do that.
Thanks very much, John. Peter? Some slides as well.
I do. All right. So I don't have to keep turning my head around. I'm going to also bring them up on my phone here. All right, thanks. Happy to be here today. So, I have been consulting in wireless technology for 20 years, and when I started, especially I was concentrating on wireless data. We couldn't get anybody to consider wireless data for anything. I remember meetings at Microsoft saying, you guys should really be developing apps. We didn't call them apps back then. Applications that use wireless data. And said, well, we don't really see it as a $100 million opportunity yet, and that's our threshold, so come back in 10 years. Well, I think they waited too long, actually. And meanwhile, iPhone and BlackBerry and so forth launched and made wireless data popular, and today wireless data is so popular that we're having discussions like this. Not enough capacity. Networks are 10,000 times less expensive to use on a per kilobyte basis than 20 years ago, and 1,000 times faster. And and there's not enough of it. So what I'm going to do today is, whoops, I went through 2 slides here. Basically summarize 2 recent papers that I wrote for, that were published by Mobile Future. And, oops, hold on a second. I'm using too much technology here. One is called LTE Congestion Management, Enabling Innovation, Improving the Consumer Experience. And interestingly, that relates very closely to what John was just discussing. And I haven't figured out yet whether he and I are on the same side of this issue or on opposite sides, and I think it points to the complexity of the issue. The other one is how wireless is different, and that just provides some quantitative information, ways of looking at how dramatically different wireless and wireline are, and that goes back to Charles Jackson's point that some of the neutrality proposals for would have a much greater effect on capacity-constrained wireless networks compared to less capacity-constrained wireline networks. So the first paper really was to rebut a paper written by the New America Foundation. They have an institute called the Open Technology Institute. And their paper was Mobile Broadband Networks Can Manage Congestion While Abiding by Open Internet Principles. The purpose of my paper was to take some of the points they made and look at the consequences if their proposals were adopted. Their proposals really are these 3 busy paragraphs, but I'm going to just go through them real quickly. The first one was that if there are quality of service mechanisms employed, now just to clarify, quality of service refers to a number of parameters that can be controlled in a wireless connection, including whether bit rates are guaranteed or not guaranteed. If they are guaranteed, what bit rate are you actually guaranteeing? What is the priority of the traffic? How much latency can it have? How much delay in the network? How much, what is the maximum error rate that can be tolerated? LTE has a very sophisticated QoS architecture. Applications theoretically could request QoS, but the operator can also implement rules, and for different applications that it can differentiate, it can apply different rules with different quality of service parameters. So this first paragraph here says that if you do implement QoS for an application, then you have to make that similar QoS profile available for any like, an operative word here is like application, and that's not that different from what John just said. The second point was, well, if you implement this rule, then there would need to be standards bodies or some other industry-wide process for classifying applications. Meaning that every application wants a QoS now has to go through this process of deciding, well, is it video? Is it, what kind of video? They don't really go into details of what the classification would look like, but that's an important element. And then the third one is transparency. And I'll just read it. It says, there will be many policy rules. They may be complex, make it more likely that automated tools may be necessary to read and analyze the rules. And they call these verifiers. And the notion is that if an operator actually implements a set of QoS rules, that a third party, or namely the government, would then have to in real time monitor the rules. All right, so what are the consequences here? On the surface, it sounds okay, but I am deeply concerned that, first of all, what it does, the way the rules are implemented is here, the PCRF. It's called the Policy Charging and Rules Function. By the way, that's an LTE, well, it's LTE plus 3G, 2G. Just shows the general architecture for a wireless network. That oversight and those rules are implemented at the PCRF. Basically, would require government systems that in real time monitor what the wireless network is doing. What this does is that it's an unprecedented intrusion of government networks and systems integrated with wireless networks. We've never had anything close to this, but that's what it would take to implement this kind of rule. And there are also what I consider extremely thorny questions. It's that this paper presents these ideas in the context of congestion. First of all, what is the definition of congestion? We don't even really know what it is. Yes, if you've consumed capacity, but is it cell-wide? Is it network-wide? A big issue too is what are like applications? Not all video is created equal. Somebody watching YouTube for entertainment is a different video application than a medical application that is in an emergency response vehicle sending back real-time video of a patient, right? And there are probably thousands of different video applications. So is there one video category or are there 1,000 video categories, right? And video is just one kind of application. Who defines the categories? And what about hybrid applications, voice and data? If I'm doing video conferencing and I run into congestion, I don't have enough bandwidth, what I want to do usually is freeze the video or take the video to a coarser resolution, but keep the voice going through because people need to hear the voice to communicate. But there may be other applications where the opposite is true. And then what about operator-deployed specialized services that need QoS? Charles already mentioned voice over LTE. Voice over LTE will only work reliably and be able to provide what we call carrier-grade voice service if that voice traffic is handled differently. And then John really touched on that. You know, what is the definition of specialized services? And then what about QoS used for other purposes? What about if I just want to do a background download of the firmware update? It doesn't matter if I get that firmware update now or 3 hours from now, right? If it's something that happens once every 3 months. How does that handle? So I really see I see a lot of questions that will take a long time to define. I also see that that process would interfere with the innovation cycle we have today. So if you look at how mobile apps are deployed today, an app developer defines the requirements, they develop the app, they submit it to the App Store, and it's available on sale. With this new regulatory regime over QoS, you develop the app, and then you have to determine, well, if I'm using QoS in some way, what category does it fall into? I have to go through this regulatory compliance step before I can even submit it to the App Store. And then the operator has to integrate that app with the transparency system. And I just see this whole process ballooning out and making app development much more difficult than it is today. So that is the first paper, which is available on my website, www.wasabi.com. Everything I've published is there, and you can find that very easily. And then the other one is actually less complicated, but equally important. And these may be points that you're already familiar with, but this was my other paper, reiterating points I've made over the years about how wireless is different from wireline. Essentially, the resources differ vastly. The capacity is far lower. Radio connections are dynamic, and Charles pointed to that. If you have a poor signal, the network can only get, has to employ less efficient modulation, more error coding, and for various reasons, your performance is going to vary moment by moment. And this is a good thing. If we didn't do that, if we look back at 2G technologies that just use the same modulation, same coding for everything, you end up with much lower aggregate throughput. The fact that our networks are dynamic means we're extracting every bit per second we can out of the available spectrum we have. And to be able to use that resource the most effectively, traffic management is essential, and treating all packets the same undermines the consumer interest. That's exactly what Charles was saying. And the other thing is that the mobile technology and the entire mobile ecosystem is evolving so quickly that any regulatory constraints will impact development. One way of looking at how different capacity is to consider the capacity of wireless with the capacity of fiber. And what these circles show is that those are 3 strands of fiber optic cable. And if you look on the left, that's 1 fiber strand. That red dot is basically showing the entire achievable capacity across the entire RF spectrum to 100 gigahertz, right, is 10% of 1 fiber strand. So 1 fiber strand has 10 times the capacity of all usable radio spectrum today. And mobile broadband spectrum is only 500 megahertz of that 100 gigahertz, 1/200, right? So basically, 1 fiber strand has 2,000 times the capacity of all mobile broadband spectrum. And the way you can see the consequences of this is in this table that looks really busy, but I'll just choose 1 row, 1 column. And what I show on the left side are different types of applications, and they're all actually video applications, beginning at YouTube at different YouTube and then Netflix at different resolutions. But if you take, let's take the second row. That's just Netflix at a fairly low resolution of called 720p, and that's not like a high definition. That uses 3 megabits per second. In an LTE network that is in typical deployment, 10 plus 10 megahertz, just 6 users, representing 2% of the subscriber base for an operator, just 6 users can consume the entire network capacity of that LTE channel in a deployment area. Right? So a typical LTE cell in the metro area might be 3 city blocks. The point is that, there's in red on the bottom, a tiny percentage of users can consume all capacity. So, in conclusion, despite good intentions, additional wireless regulations will likely have adverse unintended consequences for users, for the efficiency of networks, and for the ability of network engineers to manage them efficiently. Concludes my presentation.
So, I'm hoping to do just a few brief questions, some moderated discussion between the panel, and then open it up to questions from the audience. So, be thinking, be ready if you've got any burning questions, feel free to interject. But John, if I can start with you, I feel like Peter's presentation sort of teed up a number of questions about, and to us, I think some general agreement on the panel that reasonable quality of service is a good thing. So I think that, but a lot of the questions remain of how that gets implemented. I'm curious if you agree that government oversight of particular case-by-case quality service questions is necessary, if that's a fair characterization of your concern.
Well, my concern is having this complex regulatory system that classifies applications and then dynamically monitors operator networks in real time to make sure that the rules are being followed. And that just, to me, seems incredibly unwieldy.
So John, do you like to respond?
Yeah, I think to some extent, Peter and Chuck both make very good points, but I think in part they are arguing against a policy that we don't know yet, but that would surprise me a little. The idea that all bits have to be treated the same, or all packets ought to be treated the same, is not what the 2010 rules look like. I think I'm hearing 3 separate issues. I kind of want to pull them out and separate But the 2010 rules said, so one of the issues that we are in a sense talking about is on what criteria can you discriminate. And the 2010 rules, for example, never said, and for good, well, never said everything has to be treated equally. They said you cannot discriminate on basis X, Y, and Z. It's very different. I personally would never argue that you can't discriminate between the person who is close to the cell tower and the person who is far from the cell tower. For Chuck's example, is exactly right. But that's very different from saying I can't discriminate based on what content they are looking at. And that's a different kind of, that I think you could put in a prohibition, and I don't see all the problems that they're talking about. Maybe they will disagree occurring if that's the kind of limit. The second issue is who decides, which is what you raised in quite a lot. What is like, who decides what's like, who decides what, if things can be treated differently, who gets to decide what, my answer to that is let the users decide. That is, service providers can offer Class A, Class B, Class C, and the users will decide whether they want to use Class A, Class B, or Class C. And if they create Class A that they think is for video, and somebody says, hey, that would be great for my multiplayer video game, so be it. But if you're right, if the ISP decides, then things get very hard and very complicated and very problematic. But maybe, again, people will disagree on that. The third issue is enforcement. And as your case by case would make me a little nervous without clear criteria by which to adjust, to approach case by case. But to some extent, we don't know the future. There has to be some.
So do you think just a simple no blocking, no discrimination on the basis of source of content would be sufficient, or is that?
Never that simple. But I think you could say, with the exception of security threats and all sorts of carve-outs, I would not like to see discrimination solely based on content, solely based on application, solely based on user. I would not have a problem with, discrimination based on technical characteristics like the signal-to-noise ratio at the receiver, or discrimination based on traffic volume. Maybe you slow down the ones that are consuming a particularly large amount of capacity in this cell at this moment. Because those are technical criteria that are not about content application user. But the things I'm afraid of are things like, 5 people want to stream audio to consumers. I'm going to let one of them have good quality of service, but the other 4, they're just not going to have access to that. Guess who's going to win in the market? Or, I like the content. I like the consumer reviews that says I'm a wonderful ISP, but I don't like the ones that are critical of me. That's content discrimination. But there's no reason for this.
So let me just ask you, John. So what if an ISP wants to provide a higher tier service that's not in wireless? It wouldn't be necessarily guaranteed throughput like you over cable modem, but say, well, we're going to offer a video preferred service, or just a higher throughput, or on average a higher priority service, and it'll cost an extra $20 a month. Is that discriminatory?
So I don't have you said that 2 ways. I don't have a problem with, there's a higher quality of service where you can expect better throughput and you'll pay a little extra for it, and anybody who wants it can get it, right, and similarly situated for whatever they want to do with it. Right. I do have a problem with, only this user can get it, or you can only do it if I look and see you're doing video, or.
So one thing I want to add, that the whole quality of service thing, and it's complex, especially in wireless networks where you have constrained capacity, because if any amount of throughput that you guarantee to one set of applications is essentially diminished capacity for everybody else. Right? So even when operators turn on voice over LTE, that voice is going to have higher priority. So if there are a lot of voice users, then there's less capacity for everybody else. Now, fortunately, voice only uses about 10 kilobits per second of throughput, compared to that YouTube stream there at 1 megabit per second, or Netflix at 3 megabits, right? So YouTube is 100 times the demand on a network over voice. But so I'm just kind of sort of curious then, if an operator offers voice over LTE using a higher priority, if the logical conclusion of that New American Foundation paper is that, well, then they have to offer a like quality of service to anybody else wanting to do voice over IP. Meaning that Google can now use the same QoS parameters, and Apple can make it available for their FaceTime users and so forth. And that is a logical outcome of treating all like applications in the same way. So I'm just curious how you view that scenario.
See if I fully understand it. We should also say, you know this, but there are engineers who've spent an awful lot of time figuring out how to do very sophisticated kinds of QoS and discrimination, particularly in LTE and in some other contexts as well. They did that for a reason, which you just stated. In general, I think I am worried about the concept of allowing high quality of this application for this provider and no one else. That is normally a problem. Now, we have a history of voice, and I've actually argued in my more detailed specialized services work that perhaps you might carve out something that, if it is regulated as a telephone service, it might not be regulated under open internet. But if you apply that same logic to video games, then I would have a big problem. Because where cable, we have, for historical reasons, cable and telephony are different, for good or for bad, and that's not going to change overnight. But
Though where we're moving to is where voice is an app, it's a data application.
When it gets to that point, we could have real competition among VoIP providers and not have one favored that with good quality of service that no one else can compete to.
So you're saying that if Verizon wants to use quality of service to provide carrier-grade voice, that they have to make those mechanisms available to competing voice services?
No, I've specifically said that because of the history of telephony and because telephone traffic is telephone communications is regulated as telephone communications, it should be treated that way. And we don't have to do that with telephone traffic, but going forward with new applications. I'd also say that, and also another way to do that is if you separate even with new applications, if you separate the capacity, you say, I've got dedicated capacity that is good for nothing but this application, I think of it different. But when it's just all in the same pipe, it's an application running over internet.
A couple of reactions to that, and it gets back to why one of the reasons I'm not so worried. John's concerned about specialized managed services as a loophole. For me, they're an escape hatch, and I'm quite confident that between engineers and lawyers, they'll be able to find ways to avoid many of the feared harms or benefits, depending on who you are, of network neutrality. And the kind of thing I think of is, there's a service that many businesses buy called carrier-grade Ethernet. And if Verizon started delivering that over Fios to residential consumers, who then used it to call their ISP, it would take the FCC 5 years to figure out what to do about it. Because if they tried to shut it down, they'd have all kinds of problems. If they made a standstill, it would, screw up all kinds of business growth, because they'd have to say, well, you can't sell this to residences, but you can still sell it to businesses. And just because somebody says he has a home business, he can't get carrier-grade Ethernet. So there are all kinds, and one of the nice things about carrier-grade Ethernet is it has all kinds of wonderful QoS capabilities, and it'll always pass from firm to firm. So there are all kinds of ways. Similarly, if you're going to say, if you provide voice over LTE with some kind of priority, then you're going to have to provide comparable priority mechanisms to all of the users. Then you'll find that LTE Advanced 2 will carry voice as a separate service instead of over IP. And consequently, these rules will no longer apply. Now, it takes a few years to roll out. Then after it starts rolling out, the FCC will either have to say, Verizon, you can't use the most efficient technology, or, oh, okay, well, we'll figure out what to do about this, and then there'll be 2 presidential elections before they finish their analysis. And so I'm very optimistic about the future. I'm usually a very pessimistic person, but here I think lawyers are inventive, engineers are inventive, the technology is pretty good, so this is not going to be a train wreck, even if you think that there's a lot of flawed reasoning in the analysis. I'm sure some people in the room do.
Well, there's also a question, and I know this from discussions with operators, whether to even make the QoS, whether to provide APIs, application programming interfaces for QoS. Because it does raise this problem that the more applications that are getting QoS treatment, the worse everything else is going to be. And it's not an issue, except when you're in congested situations, but and so the operators are, truthfully, they're struggling with, is there even a business model here in these capacity constrained networks? Will people actually pay more for service that is better? Especially when you can't really qualify how much better. They can't really offer guaranteed bit rate. I mean, that's what people would love, guaranteed bit rate. Netflix would love to have guaranteed bit rate for every user. You just can't do that. And it goes back to Charles's explanation that the user at the cell edge, to guarantee them bit rate, a guaranteed bit rate, you might end up having to dedicate so much of the radio resource that you just consumed it in a small number of users with poor connections, right? So whether operators even do this remains to be seen.
That's the heart of the analysis, the example I gave, how a system that doesn't discriminate among bits and supports voice has maybe 2/3 the capacity of one that will serve the same amount of voice, but when there's idle capacity in the background and their applications will tolerate more delay, it can communicate that. But basically, a system that supports voice has to keep capacity in reserve for those situations in which all the voice users or a good fraction of the voice users are in less than average communications conditions. And if you don't have a QoS, then you just have to say we'll keep that buffer in there to be able to provide the service, or we'll support fewer users. And it's just the laws of physics. Can't get around it.
I don't see any problem with an ISP offering a service that continues providing good service even when there is heavy usage and congestion, that is good for VoIP, and another service that backs off when congestion is high, that is cheap and good for peer-to-peer file sharing, for example. I don't see if the rule.
Let me interrupt, John. You're handicapped because you've studied so much engineering. And the problem is that there are a lot of people who do policy analysis who don't have your background, and they say, all bits be treated the same. Or we know that there have been multiple pleadings that way in this proceeding, and who knows who's going to be in charge. So what the lawyers and engineers will do is they'll find a way to get it without calling it that.
There are, in any rulemaking, there is the potential to come up with bad rules. But there's also, if the rules are well crafted, there is no real risk that I see of what you're talking about. If the rules are well crafted, there is no reason why ISPs will, for example, choose inefficient technologies to get out of them. They will do perfectly fine applying the rules. Unless they're trying to do something truly anti-competitive, in which case it's not a bad idea that it becomes more costly for them to adopt anti-competitive practices. And there are people in the FCC who understand these issues.
Well, yeah, well, I mean, in your position, you talked about market power and concern about market power. If we're concerned about market power, which, people have studied that for a long time, we have traditional tools, rate of return regulation, price caps, government ownership, whatever. But if you're concerned about, if you have a firm with market power, then what you want is optimal discrimination. The last thing you want is prohibiting discrimination. You want to get efficient pricing, and in that case, you know, just the way I like to think about it is you want low prices for the poor, high prices for the poor. I mean, you know.
So I've got a question that I think might help.
Did you want to ask a question?
No, this is a great discussion. I appreciate you. Well, by all means, continue. But I'm wondering if it can sort of help approach from a different angle. And I'm curious about Charles' explanation of the lead-batch protocol, that BitTorrent's willingness to essentially change the protocol to become something of a scavenger class, right? And to what extent is that an important part of this conversation? Not having QoS that necessarily just makes a service better, but also having a situation in which those are willing to sort of back off, either in terms of bandwidth or other metrics. And secondly, how much of that will be a problem? It seems like there's not the same sort of market incentive. Nobody's going to be wanting to pay to be relegated to a scavenger class. Does that make sense? And how do we solve that problem?
Well, I think it's worth noting that through application innovation, that some of the congestion and capacity management problems are being solved by the app developers. I think probably one of the, way worse than LTE, I think the most capacity-constrained networks I regularly use are hotel Wi-Fi, right? Because everybody is like watching Netflix, so I don't know what they're doing. But I know they're consuming all the hotel's bandwidth. And it's probably not over the Wi-Fi connection, it's usually the hotel's connection to the internet. But interestingly, if you look at Netflix, and so this is something I look at carefully, is what do apps do? And if you look at how Netflix works on a laptop, say, is it dynamically is monitoring the amount of bandwidth, basically how much of its buffer, how quickly its buffers are filling on the device, and if it detects that it may run out of buffer, meaning the video is going to stop, and it keeps a few seconds or a minute or two of extra video buffered up, it goes to a coarser video. It dynamically adjusts itself, and you can see it that suddenly everything doesn't look as sharp, right? Kind of grainy and blocky, but it keeps coming through. And then suddenly it gets crisp and really detailed, and I'm thinking, oh good, somebody else stopped watching. Right? But basically the app developers themselves, to a large extent, I think, may solve some of these issues. And that's similar to the BitTorrent going to the scavenger mode. I don't know the details of that, but I can only imagine that it's doing something comparable.
No, it did something very comparable where they sensed the delay and they weren't as 0-1 in their control. They're much more sensitive in their control. So once delays started growing, they cut back.
Right.
So it wouldn't cause the same sorts of problems to deal with.
Yeah. You can even go into Netflix and deep in their settings for your account, you can say, just always give me crappy video. And you might think, well, why do you want to do that? But in fact, then you can use Netflix over, say, an LTE connection. It runs about 300 megabytes an hour, which is, somebody's on a 10 gigabyte plan, that would give you 10 gigabytes, 300 megabytes, 3 hours, 30 hours of video to use up your month's quota. Well, you wouldn't want to do all your video watching, but if you're desperate for some, for a break from a busy day at work and you can't get a connection elsewhere, you might just watch a show, right? So I think that is an interesting element of this discussion.
So lots of things can be solved at the end.
Right.
But not everything. You can't, the example of this VoIP might be more important than this can't be done at the end system. I make 2 points. One, I'm going to come back to who decides. One of the problems, I testified on Comcast and BitTorrent, I hate to go back there, that it's ancient history, I don't want to beat up a company, but one of the problems was Comcast decided which traffic was more important, not the end users. The other problem is another problem is they didn't tell anybody that they'd made the decision. But if I can choose your scavenger class as opposed to being assigned to it without my knowledge or consent, even with my, that's okay. Which brings me to so who decides? End users should decide. Which brings me to the second point. That only works if there, which you raised. That only works if there's incentives. So, for example, if if Verizon can tell me that if you take scavenger class, I won't count those bits against your monthly quota, now I have incentive. That's a pricing incentive. But it's why differential quality of service often needs to go with differential pricing in order to give end users, assuming end users have a choice, the incentive to use things efficiently.
I guess we've got about 25 minutes left to check to see if there are any questions from the audience, anything. Please.
Zachary Bastian, Time Warner Cable.
Oh, thank you. I was curious just because, the rulemaking tomorrow, they're going to vote on these rules, and a lot of what you guys have said so far underline the fact that this is a bunch of really complex engineering concerns, that it's hard to translate constructively into a regulatory or a legislative context. Do you think there are constructive ways for the FCC and Congress to get involved in these issues? Or are there specific points of entry you see where things could happen that would be beneficial to the networks as a whole? Or do you think do you guys have the more realistic or cynical, depending on how you look at it, that that's just not possible with the system as it is?
Well, two of us have spent a good part of our career in various ways in the regulatory process, either in government or outside studying it or working with it. And sure, it's a real challenge for lay decision makers who don't have an engineering background to deal with these issues, which sometimes are complex. But history shows that often they do, I'd say on average, we've done pretty well in these technical regulatory areas in the U.S. We could have done better, but we sure could have done a lot worse. So I think it's possible to write such rules, and I think it's also been my experience that sometimes when bad rules come out of the rulemaking or the bad law statutes come out, that when it gets time for operations, that the people who have to deal with the real problems find creative ways to deal with the dilemma presented by the conflict between the technology and the statute, and things work out better than you might expect.
So actually, I'm a career engineer, but I've both done a stint in the House Energy and Commerce Committee and a stint as FCC chief technologist. I believe very strongly that it is Congress's job to give high-level guidance. It is the FCC's job to plunge into the details. Both of those things can work. If either the FCC goes too far in high level and ignores Congress, or if Congress tries to micromanage, it can go badly. I think the FCC has the capacity to make hard technical calls. They've done it before. There are ways they can improve it. I wish they would add some new features, but they have those capabilities now, and I'm hopeful they can put together good rules. As to whether Congress, if Congress wants to get involved, they better do more than just tweak an FCC decision. They need to really rethink the whole thing at a high level, and remember that the 96 Act is now quite out of date. They can't fix one little piece. They could fix the whole thing if they want to try, but first let's see if they can pass a budget, and then we'll go from there.
The other night I watched Annie Hall, and there's a scene, if you may recall, in which the Woody Allen character talks to the Diane Keane character. He makes the distinction between horrible and miserable. Horrible is having an incurable disease, and miserable is everything else. So in the hopes of moving us toward a policy that's not horrible, but perhaps we can agree on a policy that's only miserable, I have two suggestions here. One is we should not lose sight of the fact that whatever regime we have in place ought to have a prominent role for the use of prices in allocating scarce resources. We want the parties in the system to have incentives to use resources efficiently. I can use two quick examples. You want people who are big bandwidth hogs, no offense intended, to have incentives, for example, to compress if they can do so without significant reductions in quality. back to Peter's, and I think both Peter and Chuck talked about this. If you can do something over wires instead of doing it wirelessly, you want people to have an incentive to do that. That if you want to charge wireless high prices because it's relatively cheap to, if you can, replace them with wire. Second point, whatever the government does, they make one mistake or another. You can make a type 1 or type 2 error. It's a statistical problem. You can over-regulate or under-regulate. If you really thought, as apparently John Pickett believes, that there's going to be massive amounts of anti-competitive behavior, then you're going to want a complex regulatory scheme with the FCC, with lots of rules and all kinds of stuff, and maybe all the things that Peter worries about will happen. If you think they're exceptional, then you don't really want that. Maybe you actually want the Department of Justice or the Federal Trade Commission to deal with anti-competitive behavior. But there are costs to having an elaborate and detailed regulatory system. And before you sort of embark on that path, you want to think seriously about whether, in fact, the benefits justify the costs.
Well, I think related to, I think those are good points, and I think related to that is that we're in the early stages of defining what 5G technology is. And any regulatory scheme that we put in that's backwards looking at today's networks could have strange unintended consequences in how we architect and design future generations of networks. So I see that as another risk.
I mean, I can't disagree. I'm against horrible. I'm in favor of incentives.
In favor of miserable, against horrible.
I'm not sure I want to accept the Woody Allen formulation. But I don't see, well, we'll see what we see, but I don't see any reason to characterize the rules as what did you say, complex and onerous. And, I mean, they don't have to do that. You can say some fairly simple things like you cannot use content as your criteria for discrimination without getting into all of the complex things that one could do and would be a dangerous road for reasons Peter and others have pointed out.
But let me ask you, why would that be? We have at least 4 wireless carriers available to people. If Verizon started blocking access to Netflix or a new Netflix setup, I mean, they're in the process, in the business basically of selling people connectivity. And if you don't, the commission has mandated number portability, so it's easy to change carriers. Most consumers have a choice of more than 4 carriers. So in that world where you have that choice, why worry if one firm plays those kinds of games? There's a very good discussion of this policy in what's now an old book by the late Ithiel Poole, who was a political science professor at MIT, called Technologies of Freedom. And he talks about it, and in a world where you have monopoly carriers, like the old phone system, the old cable companies, Postal Service, and Postal Service has a statutory monopoly, although it seems to be pretty weak these days. If you're going to have monopoly, then you have to let all voices enter. But if and the alternative is to have competition and let the voices work it out, let the voices and the carriers work it out.
So, I have another question. I'm curious what we make of this problem. If I understand it right, the QoS implementation, really most valuable, fewer users get to use it, right? If we have a whole bunch of video, a bunch of bandwidth-intensive traffic being QoS marked as priority, then becomes less valuable, right?
Well, you can't even make it work.
Right.
Well, that's in the wireless context.
Right.
QoS is still
Yeah.
important in the wired context. It's an integral part of modern Ethernet networks, things like that, corporate networks. So no, QoS is important in both the wired and the wireless world. The problem Peter points out is if you're going to give one customer guaranteed quality of service, that's okay. You promise them a megabit per second no matter what, fine. You do that for 10 customers in the same cell and you're hosed,
Right.
because you can't, you can only pass out so much capacity that way while you can keep your word. And then the laws of physics say, well, if all those guys go up to the edge of the cell, they'll quit working, so I can't overpromise. I can't the difference between what a wireless carrier can do on average and what it can do for sure is huge.
I mean, I agree, but I mean, I would expect most guarantees, certainly in wireless, even in wired, would take the form of statistical guarantees. Not, even if the hurricane takes out my system, it will still. It's 99% of the time you will experience, and we can do that.
Neutral OS and Ethernet is straight priority, right, at that switching routing.
That there are systems that work that way, yeah. But
Millions of dollars worth.
But okay, so that's a guarantee. That's a guaranteed priority as opposed to a guaranteed quality of service. In any case, the fact that you cannot, that there are times when you can't give everybody ideal quality of service. A, doesn't mean that quality of service, is not something that can be offered as long as it's offered in a statistical sense. And B, if you really got to that point and people were willing to pay for high quality service, you build more capacity. There's no, you build more towers, decrease your cell size, and then you'd have more capacity.
So do you think that it ultimately comes down to just a pricing problem? If we get the pricing right and the information over how many people are using how many quality bits, then we can build a proper capacity. Is that how we solve it?
Per the gentleman's comments, if prices are aligned with, efficient use of resources, then yeah.
We don't yet know if people are willing to pay more, especially because you wouldn't be guaranteeing, you'd be telling them, well, on average, you'll have a better experience, right? And we just don't know from a business point of view if that's something that people can sign up for.
Any other questions from the audience? So I'm curious, what are you most worried about will come out of these rules tomorrow? What keeps you up at night? What do you think is going to be the major problem, major sticking point? No concerns. Flowers and sunshine.
Well, I think it'd be going back to some of what Charles said, which was something that makes it hard, really difficult to be able to prioritize it all, something that treats all bits equally. I think that would be disastrous.
Yeah,
I don't think that will happen. But
I'm a little
that
concerned
is
about
the worst
what
case
it'll
scenario.
do. The wireless industry is not only has all these weird technical issues that distinguish it from the wireline industry, but there are a large number of suppliers. Consumers can move easily from one supplier to another. So I can easily see a regulatory regime that does impact wireless is adding several percent to consumers' bills over the next few years, and I think that would be very unfortunate. And to the extent that the rules turn out to be somewhat binding in the wireless industry, then they will mess up the design. They may lead to inefficient designs in the 5th generation that are, as I say, escape hatches, ways to design the service so that the rules don't apply, and it requires a new round of rulemaking, which means the technology will have used half its life up before the new rules apply, but then they'll be rolling out a new generation. So I think that's the kind of worry I have, is just that it will slightly impair the industry. Consumers will pay several percent more than they would otherwise.
David, if you like it. But I've got an issue, I think, somewhat down in the weeds, but I've been curious about it myself and would like to get some engineers' opinion on it. But these new upcoming technologies, software-defined networking and network function virtualization, I'm curious if one of you would be willing to explain a little bit about what these technologies are, what they do. I'm sure you can do it better than I can. And I'm curious, first of all, to what extent they change the economics of these problems, whether or not this will make it easier or more efficient to offer these sorts of specialized services. And I'm also curious if you have any thoughts whether and to what extent if you're willing to opine on the sort of legal distinctions between information services and telecommunication services, if you think it'll have any impact on that distinction going forward.
Well, the audience will be glad to know I did not bring my slides on SDN OpenFlow. I think, I don't think it really makes that much difference, but again, it's another tool that will allow carriers and other service providers to design systems that don't look like old services, and therefore create more work for lawyers, more confusion at the FCC.
I guess you want an explanation. This is hard to do without his slides. So there's a move to shift functionality in switches that has historically been in hardware into software. This has more implications than we want to talk about here, but among them, it means that you can sort of centralize decisions on an approach and distribute it throughout. It used to have to be done in a distributed way. It might have some advantages of offering differential quality of service. Certainly there's some cost importance to this. I think in net neutrality, I don't think it's a game changer. It may have some advantages in terms of offering services with differential quality of service.
Well, as you said, OpenFlow allows you to look into basically the fourth layer. When you're, the routing tables in OpenFlow look at Ethernet address, the IP address, whether it's TCP or something else. So it is a tool for much more fine-grained discrimination.
But that's just where then where an operator would be deploying in their own network, right?
Right, but if you're a wireline operator, you're providing service, it's an unencrypted connection, you can see what port it's going to and route on a terminating port.
And you can do full deep packet inspection now. So I mean, it doesn't make something
No,
that
it
was
just-
technically impossible before
it
it's
just-
technically
it just-
possible, but it may make it more cost effective.
It makes it deployed everywhere.
Yep. I will buy all that. On the last point, and I'll come back to, we have definitive, I hope Congress will come back to the fact that the world has changed since 1996 and give us some new definitions. It's a very good thing for them to do, but until they do, we have very clear definitions. Is information changing in form or content as it goes from one side to the other? I personally don't see how the existence or non-existence of SDN fundamentally changes the decision of how it fits in the 96 definitions. And in fact, I'd be worried about definitions where a new generation of technology, something happening, underneath the covers that no one else could see, would change your legal definitions. We do not want regulations that change from that sort.
But John, if you accept that, then wireless is out of the game, because all the wireless carriers, they're delivering an image to a smartphone. They take it from a JPEG that's 1,000 by 1,000, press it down to 300 by 300. It's still a JPEG file, but it's been changed in content. And I mean, some of the carriers allow you to turn this off, but that's, there's certainly a time where we would say recompressing an image was clearly data processing, and that's bundled in with wireless service. And so if you're going to say that's a crisp definition of information service, then hey, no problem with network neutrality for the wireless industry, because it's nothing but information service, and the FCC couldn't reach it with Title II. You don't believe that?
That is again, separating policy from legal authority. What you just raised should be discussed on whether Title II is a valid legal authority, and I'd still say, this handset is not what my wireless service provider provides. What my wireless service provider provides is the transmission of information from one side to the other, and what goes in on one side is exactly the same as what comes out on the other.
Verizon takes a JPEG from the website, and if it's 1,000 by 1,000, maybe turns it into 300 by 300, and sends that 300 by 300 to your handset, which displays it.
From its own website you're talking about?
No,
Somebody
from
else's?
Carnegie Mellon's.
Okay, then what?
Carnegie Mellon sends me 1,000 by 1,000 JPEG, and it shows up as a 300 by 300, thanks to Sprint or Verizon.
And
That
is happening inside, that is happening at the edge devices, that is happening inside the switches.
No, I think Charles is saying it's happening within the network.
It happened before it went out over the radio channel. That's the whole point.
Right.
That's true.
You get a 10-fold decrease in the bits consumed, right? 3 or 9-fold. Well, no, a little bit more than 10-fold in my example.
Charles, are you
It's
saying
like
this is a
million
good thing or a bad
pixels in
thing?
one case was 90,000 on the other.
It is also true that in telephone networks, you can be analog on one side and digital on the other, and we still call that Title II. So the question will be, is this level of transformation more or less than that level of transformation?
I mean, in Computer 2, the FCC said converting from ASCII to EBCDIC was data processing, but converting from ALA companion to MULA companion, which is also an 8-bit mapping, is not. That is an example of the kind of pragmatic decision-making when problems arise that I commend the FCC and FCC staff for. And that's what's going to happen whenever a hard problem comes up, the FCC is going to say, that's not what we meant. That's why it isn't going to be a train wreck, it's just going to be a little inefficiency. But go back and look at it. You know, ASCII to EBCDIC is data processing, and MULA to ALA isn't. And it's the same thing, mapping one set of 8-bit characters to another.
Model of clarity going forward. I think if nothing else, this discussion shows that there are a lot of ongoing questions that will need to be resolved, regardless of whichever way the FCC or future congressional legislation goes on this issue. I hope that we have got folks as smart as these three out there trying to help solve these ongoing questions.
I'm not even sure if brains help.
All right, thank you everyone, appreciate it.